name is Jaime Banda, and I'm a team leader here in the audit on Redshift. And my safety commitment is that I'll do everything within my power to get through each day safely and encourage all my team members to do the same. We have another great problem-solving activity for you today. Now, I must say, I've been in a lot of quality circles, and this one was probably the most challenging one for me. As a team, we ran into some brick walls. We managed to pull out a few hairs, but we kept our resolve by keeping our eyes on task, minds on task. As a team leader, it is imperative for me to continue in my development skills as far as problem-solving activities and my leadership abilities. And it just so happens that I have a team member on my group who had been through the team member to team leader development training. So I thought this would be a great opportunity for him to develop in his leadership abilities and be the team leader of this circle. So without further ado, I'd like to introduce you to the team leader, Joseph Price.
Good afternoon, everybody. My name is Joseph Price. My safety commitment is I will always work safely and report all unsafe acts. I'm fairly new to the QA department, and this was my first QCC I've been involved in since transitioning from assembly. I needed to have a QCC under my belt as part of my team member to team leader development. So I thought this was a great opportunity for my personal development. Now, let's talk about Team Bromine and our 8-step problem solving activity. So, this is Team Bromine. We have our advisor, Felix. We have Jaime Banda, the QCC leader. Myself as the theme leader. Leo Rodriguez as the gatekeeper. Mark Edwards as the scribe. And Isaac Galaviz as the timekeeper. Now, due to QCC guidelines, unfortunately, those guys weren't able to report out with us due to social distancing, but they did uh, have a big impact on our project and our quality circle, so they were fairly involved. So this is our QCC story record sheet. Our theme is to improve and stabilize shower water concentration levels. Though we have though we had many themes that scored high, including drizzle head cleaning, our chlorine levels was the one that scored the highest. Now, because this one scored a 24 also, we can always go back and revisit that one on our next QCC. But we chose our chlorine levels. Would that make our work easier? Much easier. Was it a vested interest? Interest? How many team members impacted? More than 50%. Can we solve by ourselves? We can't do that. Can we complete in time? We can't do that also. What will happen is if the problem is not solved, it will gradually get worse. What will benefit to the team? Our safety. So like I said, that one scored 30 points. We decided to go with the chlorine levels, but Drizzlehead also scored high, so we can revisit that one on our next QCC.
Thank you, Joseph. So now we're going to go over our activity plan. As you can see on the left-hand side, we did do our assessment on the team after a couple of weeks of working with each other. And we are in Zone Z. That's only because the team members that were involved in this activity have had prior QCCs and were very helpful through this whole thing. So our goal was to continue and improve on our technical capability as well as our circle dynamics. You can also see the 8 steps listed, who was responsible for that step, and what development opportunity was it for that team member specifically as we went through the quality circle. You can also see our timeline, our planned and our actual, and we did pretty good starting off, and then we ran into the holidays. Everybody came back maybe just a little bit lazier, but we managed to get back on track, get through our trial activity, and complete the quality circle by February 2020.
So this is a little overview of our shower and drizzle. So this is our drizzle bay. You can see this is where we do our 4-hour drizzle. This is our holding tank here at the bottom. This is our bromine over here where the chemical is. It has 2 tubes that go through the wall and are plumbed to a timer pump. Next, I'll be showing you the shower. This is our shower bay where our 10-minute evaluations happen. The water drains into the pit and then is returned by a pipe back to our holding tank, which is then sump pumped up back over here to our filters. This right here is going to be our timer and our pump setup. These are our filters that are pumped from our holding tank up through the filters and used for our shower and drizzle evaluations. So the filters just clean out the debris, so no rocks and debris go through the drizzle heads. So on step one in clarifying the problem, our shower water must be tested for halogen concentrate levels to meet requirements set by TSMS process 53, water Legionnaires control. The chemical we use in our area to help the water sanitize is called CL49, which is automatically dispensed by a pump set to turn on once a day for 10 minutes and for 20 minutes on Sundays. CL49 is a mixture of chemical needed to prevent waterborne disease. The two main chemicals in CL49 are bromine and chlorine, also referred to as halogens. We currently test for chlorine levels before the start of each shift using a 5 ml free chlorine test. The levels per standard should be at least 0.5 to 1 ppm, parts per million. Team members have noticed fluctuations in spikes and reading on a regular basis. What causes the fluctuations and how can we countermeasure is our focus activity. So if you look, our free chlorine levels have measured out of standard 97 times in a 3-month period. Of course, our ideal situation we want is to have 0. Our gap is 97 measurements out of standard. Our ultimate goal is to provide our customers with a safe, high quality vehicle with the shortest lead time to ensure on-time delivery, and always confirm the shower water halogens are within the required standard at the start of each shift. So the test results is, at 124, we had 97 out of standard. 78% of our standard, 78% samples out of standard.
All right, Joseph. So I'll go over step 2. We're still in the planning stage of our quality circle. And I know you're thinking to yourself, wow, 97 times, but we'll get to that. So 97 concentration levels have been determined to be out of standard. When were they found? June, September, and October. How many? We had 26 in June, 32 in September, and 39 in October. So we wanted to focus on October samples. We had 1 that was below the 5.5 ppm, and we had 38 that were above. So we broke that down a little bit further. In the AM, we had 21 that were above, and in the PM, we had 17 above. And as you can see on our QCC tool control chart, we had no control over this at all. Our goal was to try to get control of this. You can see our target lines here, and we're way above it. Now, as far as the process flow, the team member runs the shower for 10 minutes. The team member preps the test materials. He collects the water sample. Then team member visually confirms the concentration level with the colorimeter that you see in front of you. And then the team member notates the reading on a TPM and then begins his daily activity. So the prioritized problem at point of occurrence will be the team member visually confirm concentration levels out of standard 21 times during the TPM. Also on the top right-hand side, we did some Ginchi Gibutsu at the beginning of the circle. You can see that the water tank is drained weekly. The water comes from the city already with chlorine and bromine added. The dispense pump we seen was programmed to dispense 137 ounces of CL49 weekly. The test kit that you see in front of you is ideal for what we're doing and our measurements. And we also went inside the plant in the shower line to review their process to see how they maintain their levels. So step 3, we're going to set a target. We're still in the planning stage. So our target is to establish a plan that would eliminate our current gap and stabilize the concentration levels by January 30th, 2020. So you can see on the first graph here, we're focused on the 21 that are out of standard in the AM. Ideally, we want to bring that down to 0. So if successful, our countermeasure would bring our current gap to 0 and would reduce our overall gap down to 76, which is a 21% reduction. Now, before we get into step 4, this is the part where we start pulling our hair because we had to really think about the root cause. So we talked it over as a team, and I told the team members that on our team selection metrics, we said we can do it by ourselves, but there's a lot of times that there's a lot of resources out here that we can use. All we had to do was make an effort to reach out to those resources, and we did. So our brainstorming process, we did some Gitchigibutsu. We reached out to PE by phone and met with Don Castet before the start of shift a couple of times to review our process. We had some questions based off our own personal research. We then met with the supplier of the chemical that we wanted to get their perspective also to understand what we were reading because it really got complicated. So as you can see, Don has 40 plus years in industrial water treatment, and ChemTreat has been here since 2005, and they provide all the chemicals that help keep the different areas water sanitized. So it was very important for us to talk to these gentlemen, and they were very helpful in us finding our root cause. So now I want to step forward, analyze the root cause. As you can see, Leo Rodriguez, who is not with us right now because of CDC guidelines, but he had a big part in this. So we're still in our planning stages. So we're going to go with man, material, machine, method, and environment. As you can see on the man, team members are certified in process and they're following their standardized work. Under machine, you can see that the chemical dispenser that we showed you, the shower pumps, and the chemical drip line. All of those may have contributed, but not really the root cause. Method, team member collects sample, measures the sample, notates the sample, and then the test is complete. And then as far as environment, we found that the air temperature, water temperature, and sunlight can have an effect on the chemical levels that you have inside the tank, right? But this is mostly if the water is exposed to sunlight and a lot of heat. Our area is concealed, it's covered, the door's always closed, and we're in a controlled environment, which we really didn't think that the air temperature, water temperature, or sunlight was affecting our readings. So if you look at material, free chlorine levels are out of standard. Why? Concentration levels could not be managed. Why? Water sample spikes and affected. Why? Free chlorine tests react negatively because of the high bromine concentration in the chemical itself. So the free chlorine test is designed to measure chlorine only. So there was an interaction there because there's 7% chlorine, 15% bromine. Every time we added 5 minutes or 10 minutes of that chemical, the free chlorine would react negatively, and that's why we're seeing a lot of spikes based off our research and our resources. Now you're thinking, what do we do to try to control this, right? So there was a couple of times we had to empty the tank because the levels were just way too high. But there were some times that we drained for 5 minutes, filled it for 5 minutes, and we're able to control it just a little bit better and bring it within the standard. So the root cause, based off our go and see activities within the plant and the information we received from our outside resources, we as a team strongly believe that we had found the root cause and was ready to move forward.
So we're still in our planning stage. On step 5, we're developing our countermeasures. So some of the countermeasures we came up with was have maintenance do the monitor and maintain the chemical levels for us. Probably wasn't a good idea. We couldn't do that by ourselves. We wanted control of this. We wanted to be able to keep it within standards ourselves. Switch chemicals from a chlorine mix to a chlorine only. Reroute the bromine dispense tube and trial, and that was an easy fix. We went ahead and took care of that. If you can see right here, the bromine tube was dumping the bromine into a trough, and it wouldn't mix into the tank until the water was actually turned on. So on the weekend, it was kind of a waste of material. The countermeasure we did go with was order and test the new test packets. So the cost was low because the packets cost the same. The effectiveness was going to be medium. Feasibility was high. Durability was high. And the influence was high. We believe the countermeasure will work because it was designed to measure the chemical used in our process. So this is the current test kit, the 5 ml free chlorine, and this is our 10 ml total chlorine. So on step 6, our CR countermeasure, we're in our due stages, our activity plan. So we wanted to order the new test packets and communicate activity with the white shift. We coordinated rerouting of the dispense tube with PE. We discussed leaving the tank empty over the weekend with white shift to allow tank to dry to eliminate adding CL49 on Sundays, which we did. The water comes from PE already what chemicals in it, so it's within standard. So it doesn't make sense to fill the tank on Friday and add more chemicals to it when it comes into us in perfect condition. We ran a trial for 3 weeks on both shifts in a just timer and monitored results. We began monitoring daily halogen levels with new test packets and recorded them and adjusted or revisited, countermeasured if needed. We shared the results with White Ship also. So this is the dispense tube relocation, and this is our dispense time adjusted.
Yeah, so we just wanted to show you this slide real quick. This is our whiteboard, and this is how we tracked everything that we did throughout our trial activity. Red and White Shift worked together on this. The amount of chemical that was added daily and weekly. The timer adjustments that we had to make every day to try to control. And then the before and after concentration results. And then we continue to track through February. So we didn't only do the 3 weeks. We got that data, we crunched it together. We were able to put together a chart based off the information we gathered here, but we continued through February and got some good results then too. So step 7, we want to monitor both results and processes. So remember in step 3, we wanted to focus on the 21 that were out of standard, right? So 21 out of 21, that's 100% no good. So during our trial activity, we were able to get 15 on day shift. And out of those 15, we had 13 that were good. And we only had a 2 gap. So if you look to the right-hand side, this is the whole trial activity. And you can see we have a little bit more control now because these are our targets. We only had maybe 6 or 7 that were out of the whole 30. So that was a great improvement. If you remember step 1, we had 78% that were out of standard. Now we were 77% within standard. So the benefits, 77% of concentration levels measuring within standard. Spikes and fluctuations in daily concentration samples have been reduced. 54% in chemical use, reduction in chemical use weekly to keep water sanitized. We went from 137 ounces a week to 72 ounces a week. That in turn saves us over $1,300 a year because a barrel costs $1,500 for 30 gallons. And off to the right, you can see before the trial, we were using approximately 48 gallons a year. After the trial, we figure we're only going to use about 22 gallons a year, saving us 26 gallons a year, which is equals up to $1,300. Also, the team members' overall knowledge of equipment, chemicals, and the importance of utilizing QCC tools has improved. Once again, we have our QCC tool on our control chart, and you can see we have a little bit better control now.
So in the act in step 8, standardized successful process, you can see our chart looks a little different than it did previously. So the only time we were out of standard when we had no production. And to even confirm that, below you'll see a MV test kit we received from ChemTreat. The first one on Wednesday shows the water being incubated for 48 hours, and you can see it's well within standard. And then on Friday, incubated for 52 hours, which is overtime, but it's still well within standard. We're just confirming our results. So our plan moving forward, we want to continue to monitor, countermeasure, and update as needed. We want to submit standardized work changes, requests, and implement new changes. Order digital colorimeter for reading chemical concentrations more accurately, and update best in brief and risk assessments if needed. We also shared our activity with BPACs and other NAMCs.
All right, so reviewing future plans, we want to continue to reevaluate the location of the pump to see if it eliminates air in the lines. Now, we did see a little bit of air in the lines, but it had no effect on the outcome. We want to continue to follow up with our great resources, Don Castet and ChemTreat, and to learn a little bit more. Maybe there's some more tools out there that we can use. And then review and update theme selection matrix for our next QCC. And then finally, you can see at the end of our circle, we did improve just slightly, but that's good. An improvement's better than none. So the guys did a great job. You have our meetings. We try to have a meeting every Friday. As you can see, I was out a couple of times, but Joe did a great job leading the team through each activity. All right. So now, you just want to do a quick reflection. So myself, Yeah, as a QCC leader, I've been in many, but challenges bring out the best in us when we persevere and remain focused. We want to learn what it takes to maintain chemical level. I mean, learning what it takes to maintain chemical levels in water was truly a great experience for me, and one that I would surely think long and hard about before installing a pool at my house. There's a lot of work involved in that. Some of our other team members had feedback. No matter how long you work in a certain area, a fresh set of eyes is truly an asset. Mark had a good one. He says, "Good to see attention was given to the process. The job was made so much easier and safer through this activity." Then also said, "Effort equals success. Step forward is the most challenging part of the show. This is why Getchi Kubutsu is imperative to the success of solving any problem." Joe, you have anything?
Yeah, I just wanted to say that this activity has been a great activity as well for me and the team. Not only did we get more familiar with the equipment that we use, also the chemicals we use on a daily basis. I now feel more comfortable speaking in groups as part of my development with this. I also had to reach out to different experts in different areas to become an expert in our own area to make these changes. But we feel great about what we've done here, and appreciate the opportunity to be able to do this, and appreciate the QCC as a tool that can be applied anywhere to solve the unknown and gain positive results. So this will be the time for Q&A.
Hey guys, this is Suzanne Kazunas. Thank you all for really good presentation. My safety commitment is to wear a face shield when I'm interacting with somebody 3 foot or less. You know, you said a couple of times in your presentation that the job that this made it safer. And even at the very end, in your team member reflection comments, somebody said, you know, it made the job safer. Can you describe a little bit the difficulty of, you know, these 97 occurrences of something out of standard? What did that mean to you personally? What did you have to do when you had something out of standard? So I can better understand the severity of it.
So when something was out of standard, the water levels, we would dump some of the water that had the chemical in there. We would add fresh water and then retest it and make sure it was in a standard that was okay, right? But as we got into this quality circle, we didn't know how severe is, right? So when they put standards, you say zero point 0.5 ppm to 1.0. Well, what does that mean if we're above that? Is it unhealthy for a team member? We're working with chemicals we're not familiar with. So when we reached out and we're doing our questioning with these folks from Chemtech and from PE, you know, we wanted to find out what's unhealthy. So 5 ppm is what your average swimming pool has. So if we're at 6, we're still within a healthy range. But when you see, oh, our standard is 0.5 to 1, and we're at 2 or 3, is that unhealthy to a team member? We didn't know. So after this QCC activity, we now have a better understanding of the chemical we're working with, and we know how to control it.
Yeah, so basically, it was not unsafe at the time we were measuring. From what we found out through our Getchi Kubutsu activities, and we did our personal research. So if you're going to jump in a pool later on tonight or a hot spa, just make sure that there's going to be about 6 parts per million. That's 6 times what we have in our pool over here. So you're going to get more of effect than anything else. Plus, our doors are open when we do our shower. We have good ventilation through there. So the team members felt that it would be a danger, but after doing this circle, they felt a lot safer now.
Thank you. And then when you had an abnormality and had to do the dump and had to adjust the chemicals, how much time did that take? Like, as far as the job itself?
Yeah, so that makes the job a lot easier for the team leader, right? Because he's the one that has to control, or she's the one that has to control this. Sometimes it took 5 minutes to dump and 5 minutes to refill to dilute the chemical enough to where it would bring it down to ideal standard. Maybe not 0.5 to 1.0, maybe just a little over, but still within the ideal range. So the time it took to control that nowadays makes it a lot easier, not only for myself, but for the team members. That way I don't have to impact the process as they're doing. performing their shower checks.
Thank you. Any other comments or questions?
This is Toshi. My safety commitment is I always keep the rules. Thank you very much for the very good activity and very good Genchi games activity, and also many trial could make a great result. Thank you very much, and congratulations.
Thank you, sir.
Thank you.
Hey guys, this is Kevin Vocal. So my safety commitment is I'll follow CDC guidelines to protect myself and others during this pandemic. So first of all, thanks for taking on the challenge of QC circles in this time. You're wearing masks and everything else, and we've got all these pressures. But I really do appreciate the spirit of Toyota and continuous improvement to be able to take this on. So that's my first comment to you. Specifically about your QCC, you really taught me a lot about some things in the water, and so I appreciate you being able to put a process in, especially contains something that's so important for our team member safety. In this, I'm a little curious, I guess, as most NAMCs have some shower and use water. Did you benchmark any other sites or look at their procedures to see if you could learn anything as you were investigating these?
Yes, sir. So, Kevin, yeah, I did actually reach out to TMMI, or our mother plant, and spoke with the group leader out there at the audit building, Adam. And they're still under the old system where they just use bromine tablets. They have not upgraded to the new system yet, where it is connected to a pump and they're using CL49. And then we also went inside to look at the shower line just to see how they were maintaining their water. They have a lot more water in there, but that's controlled by McKellen. So we didn't get an opportunity to speak with them. After we spoke with Chemtrade and Don Costet, we felt that we had enough to continue this activity.
Okay. Hey, thanks for that. I think maybe internally we still have some things to about why we're doing one thing in the shower one way and doing something different out here, and then maybe we can look across all NAMCs to find the best process. So I think you've got a much better process already, but we still have some things out of standard. So let's continue to follow up, and maybe we can do some benchmarking of other NAMCs and find the best process over shower line and here. So thank you.
Thank you.
Yes, sir.
Thank you very much. Another round of applause for the team. Okay, at this time, we have a couple of certificates. Mr. Chris Toves, I believe, is going to be passing out just a couple of certificates for the teams, for the team members that are there. So you could do that now. And while they're doing that, MSC members, if you haven't done so already, if you could please submit your scores, work on submitting your scores.
So this is Chris Toves, QA manager. My safety commitment is to ensure safe track processes for all of my team members. So first, I'd like to present the certificate to Jaime Banda. As you can see, Jaime's, like you stated before, he's completed a lot of quality circles, and there's a lot of perseverance, and he does really good encouraging his team members to follow his lead and do some problem-solving activities, and he does a really good job of developing his team members. So Jaime, this certificate is for you, for Team Bromine, for your completion of this QCC, sir.
Thank you, sir. Appreciate it.
And the next one is for Joseph Price. So again, Joseph mentioned he's one of the newer QA team members, but again, with Jaime's leadership and his ability to encourage his team members for their development, Joseph really took this QCC and helped lead his fellow team members and also encourage his team members to complete their problem-solving activity and their own self-development. So Joseph, this certificate is for you for Team Bromine, and again, congratulations, guys.
Thank you.